Imagine Earth without atmosphere, without ozone, without life. A frozen desert under a sun that burns everything it touches. No trees, no oceans, just silence and radiation. This is not a scene from a movie. This is what happens if a gamma ray bursts. A beam of pure energy sweeps across our planet. Not from a nearby star, not from a supernova in our galaxy, but from one so distant, its light has traveled for billions of years just to find us. On January 14th, 2019, we saw it. Not with our eyes, not with our senses, but with machines, with telescopes, with satellites. The signal came from GRB 190114C, the most powerful gamma ray burst ever recorded. It was brighter than 1 trillion suns. It lasted less than a minute. It released more energy in those 60 seconds than our sun will emit in 10 billion years. And it happened 4 billion light years away. We were lucky. It missed us. But next time it might not. This is not science fiction. This is physics. And this is how the universe kills civilizations. At 1:38 a.m. Universal Time, coordinated on January 14th, 2019, NASA's Swift satellite detected a flash. Not a flare, not a nova, a gamma ray burst. Within 57 seconds, magic, a ground-based telescope on the island of La Palma, locked onto its location. It began collecting photons. Photons with energy levels reaching 1 trillion electron volts. 1 trillion. That's 1,000,000 times higher than any gamma ray previously seen from a cosmic source. For comparison, visible light from the sun carries about 2 electron volts per photon. This was 1,000,000,000 times stronger. The signal was so intense, it saturated detectors. It overwhelmed sensors designed to measure the brightest objects in the sky. GRB 190114C was not just bright. It was violent. It was unprecedented. It was the loudest scream the cosmos had ever made, and we heard it. For the first time in history, scientists detected very high-energy gamma rays, above 100 billion electron volts from a gamma ray burst. It proved something we suspected. These events are not just explosions. They are particle accelerators, larger than anything we can build, faster than anything we can imagine, and they fire beams of death across the universe. Where did it come from? Hubble Space Telescope pointed at the same patch of sky. It found a galaxy, bright, dense, active. In its center, a region of furious starbirth. New stars forming every day. Massive ones, unstable ones, stars that live fast, die young, and go out with a roar. GRB 190114C came from such a place. It was triggered by the collapse of a massive star, over 20 times heavier than the sun. Its core collapsed. In less than a second, it became a black hole, not gently, not quietly, with a shock wave traveling at 99.9% the speed of light. 2 narrow jets of plasma blasted out from the poles, perpendicular to the dying star. Each jet contained particles accelerated to energies far beyond anything possible on Earth. They smashed into surrounding gas, generated magnetic fields, created cascades of high-energy photons, gamma rays, X-rays, visible light, all streaming toward us like bullets fired from a gun aimed directly at Earth. If that jet had been pointed at us, we would have been erased. In seconds. No warning, no pain, just darkness. Let's put this in perspective. The sun emits about 3.8 times 10 to the power of 26 watts. Every second, for 4.5 billion years. That's how long it has been shining. GRB 190114C. In 60 seconds, released more energy than the sun has emitted in its entire lifetime. That's not an exaggeration. That's math. It released 5.6 times 10 to the power of 47 joules. To understand that number, imagine converting the entire mass of Jupiter into pure energy, then multiplying it by 10, then doing it again and again. That's the energy of this one event. And it happened once, in one tiny corner of space, in one moment, lasting less than a minute. This is not a supernova. This is something worse. Supernovae spread energy in all directions. Gamma ray bursts focus it into two beams, like lasers made of death. Only 1 in 1,000 of these events points at Earth. But when it does, there is no escape. Gamma ray bursts happen constantly, about once a day, somewhere in the observable universe. But almost all of them are too far away to hurt us. Most occur in galaxies billions of light years away. Even the closest known GRB, located 130 million light years away, was still too distant to threaten Earth. Why? Because the beam is narrow. Like a flashlight, you have to be directly in its path. Scientists call this the jet cone. The angle? Less than 3 degrees. That means, in a galaxy like ours with hundreds of billions of stars, only 1 or 2 gamma ray bursts occur every 100 million years. And only one of those, maybe once every 500 million years, is aimed precisely at Earth. So statistically, we are safe. For now. But here's the truth. We've survived longer than we should have. Life on Earth has existed for 3.5 billion years. Complex life for 500 million. And yet, we've never been wiped out by a gamma ray burst. Why? Maybe because we're lucky. Maybe because the conditions needed to create a deadly GRB. Massive stars, tight binary systems, rapid rotation, are rare in our galactic neighborhood. Maybe because our galaxy is quiet. Maybe because we live in a cosmic backwater. But we cannot assume it will stay that way. In 2012, Japanese scientists studying ancient cedar trees found something strange. Levels of carbon-14, a radioactive isotope, spiked sharply around the year 774 AD. At the same time, ice cores from Antarctica showed a spike in beryllium-10. Both isotopes form when cosmic rays hit the upper atmosphere. Something powerful hit Earth around 1,200 years ago. What could it be? A solar flare? Too weak. A nearby supernova? No remnant found. No historical record of a new star. The only explanation that fits? A gamma ray burst from a distance of 6,000 to 12,000 light years. Close enough to affect the atmosphere. Far enough that we didn't see the flash. The radiation was absorbed. The ozone layer was damaged. The climate cooled slightly. The forests grew slower. And we didn't notice. We didn't even know. But the trees remembered. The ice remembered. And now we do. This may explain another mystery. The Ordovician extinction, 445 million years ago. 60% of marine species vanished. No asteroid. No volcano. No impact crater. Just disappearance. Some scientists now believe a gamma ray burst may have stripped Earth's ozone layer, exposing life to lethal UV radiation. The oceans boiled, plankton died, food chains collapsed, and the world turned silent. If true, then gamma ray bursts are not just future threats. They are past killers, and they may return. There are 2 ways to make a gamma ray burst. First, the death of a massive star. That's what GRB 190114c was. A star collapses, forms a black hole, spins rapidly, launches twin jets. Second, the merger of 2 neutron stars. 2 dead stars, each smaller than a city, orbit each other for millions of years. Finally, they collide. In milliseconds, they form a black hole, or a magnetar, a neutron star with a magnetic field 1 trillion times stronger than Earth's. Either way, energy erupts. Jets form, gamma rays shoot out. Both types produce the same result: a beam of photons so energetic they can ionize atoms 50 kilometers up in the atmosphere. When that happens, nitrogen and oxygen molecules break apart, reform as nitrogen oxides, destroy ozone. The ozone layer thins. UV radiation floods the surface. DNA breaks. Says D. Photosynthesis stops. Plants wither. Animals starve. Oceans acidify, and the biosphere collapses. It doesn't take a direct hit, just a near miss. A burst from 8,000 light years away could end civilization. We don't need to be vaporized. We just need to be poisoned. Before 2004, we knew gamma ray bursts existed, but we couldn't catch them fast enough. Then came SWIFT, launched by NASA, a satellite designed to detect gamma ray bursts within seconds. SWIFT sees the flash, instantly turns, points its X-ray, ultraviolet, and optical telescopes at the source, sends coordinates to observatories worldwide. Within minutes, ground telescopes lock on. By 2019, we had magic. Fermi, Integral, Jet, a global network of eyes watching the sky. We didn't just detect GRB 190114C. We measured it. We analyzed it. We understood it. We learned that gamma ray bursts are not random. They follow rules. They obey physics. They are predictable in their violence. And we are learning to predict where they might happen. We scan galaxies for massive stars, for binary systems, for signs of recent supernovae. We look for places where the conditions are perfect for death. And we count. We calculate. We warn. Not because we can stop it, but because we must understand. We are not prepared. We have no shield, no defense, no plan. We cannot move Earth. We cannot build a force field. We cannot escape. If a gamma ray burst hits, we die. No matter how advanced our technology, no matter how many cities we build, no matter how many colonies we establish on Mars, because the damage is atmospheric, global, irreversible. The best we can do is detect it early and pray. But here's the hope. The rate of dangerous bursts is low. 1 every 500 million years. Humanity has existed for 300,000 years. Civilization for 10,000. We are still in the safety window. We may never see one. We may live forever. Or we may be next. The universe does not care. But here's the paradox. Gamma ray bursts are not just killers. They are teachers. They are messengers. Because they are so bright, we can see them from the edge of the observable universe. They are the brightest events since the Big Bang. Brighter than quasars. Brighter than supernovae. Brighter than anything else. When we detect a burst from 13 billion light years away, we are seeing the universe as it was when it was only 500 million years old. We're seeing the first galaxies form, the first black holes grow, the first heavy elements being forged. We're looking back, farther than any other object. Gamma ray bursts are cosmic lighthouses. They show us where the universe was born, where it grew, where it changed. They help us understand dark matter. They reveal star formation rates. They test Einstein's theories. They probe the structure of space-time. They tell us how often galaxies merge, how often stars die, how often life is erased. We use them to map the cosmos. We use them to understand time. We use them to ask, are we alone? And if we are, then we are also alone in knowing we are alive. We think we are the pinnacle of evolution. We think we are intelligent. We think we are eternal. We build cities. We send probes to Pluto. We talk about colonizing Mars. We dream of interstellar travel. But we forget we are fragile. We are small. We are temporary. A gamma ray burst takes less than a minute to destroy our atmosphere. It takes less than a decade to erase our food supply. It takes less than a century to end our civilization. We have no defense, no backup, no escape, and yet we still act as if we are invincible, as if we are the center of the universe. We are not. We are one species among trillions that live for a moment and ask questions. We looked up, we wondered, we tried to understand, and that is why we mattered. The most powerful gamma ray burst in human history, GRB 190114C, was not a threat. It was a message. It said, "You're not safe. You're not protected. You're not unique. Your existence is accidental. Your survival is luck. And your future is uncertain." We are lucky. So far, we have survived. We have not been hit. We have not been erased. But the clock is ticking. Another burst is coming. Somewhere. Sometime. Maybe tomorrow. Maybe in a million years. Maybe never. We do not know. But we know this. If we want to survive, we must learn. We must observe. We must prepare. We must accept that we are not the masters of the universe. We are its children. And like all children, we must grow up. We must face the dark. We must stop pretending we are safe. We must become worthy of the gift of consciousness. Because if we do, maybe, just maybe, we will live long enough to see the next burst. Not as victims, but as witnesses and as survivors. We hope this journey ignited your curiosity. Stay with us as we explore the deadliest forces in the cosmos, the silent killers that watch from the dark, and a fragile miracle of awareness in a universe that does not care if we live. Subscribe and join us for the next discovery.